Okay, the reason I stopped the last video is because this part is extension, where the last part was just normal mathematics. So I'm going to call it extension permutation, so when you've got to revise, you can come back and look at it. Okay, with sitting around a table, if I sit 5 people around a table, it's different than sitting in a line, because if I had A, B, C, D, E in a line, if I swap the E and the A, it's different. But if I have A, E, B, C, D in a circle, that's the same as if I had E and A, because they're still sitting together. Okay, we're not worried about what seat they're in, we're talking about their relationship with each other. So, the way we do circles is we say there's 5 people at the table, it will always be 1 less factorial, 4. If there's 9 people at the table, it will be 8 factorial. If there's 7 people at the table, it will be 6 factorial. If there's 55 people at the table, it will be 54 factorial. It is always 1 less when they mention circular table. If set it at random, what's the probability that 2 particular people are sitting together? I've got 2 people here, and then I've got 1, 2, 3 people in the table. So essentially I've got 4 people trying to sit at a table. So it's 1 less, 3 factorial, and I can have these people swap spots. So that's 2 factorial, and that will give me my answer. What happens if I did 8 people at a table where 3 were trying to sit together? I'd have 3 trying to sit together and another 5 moving around. So there's 6 things moving around the circle, so it's 1 less, 5 factorial. And these 3 can be arranged 3 factorial ways. And that would be my answer. Okay, question 8. And how many ways can the words in Colleen be arranged? Because there's 2 L's and 2 E's, it doesn't... you can see that there's going to be repetition, so I can't just say 7 factorial. I've got to say 7 factorial, but I've got to divide by the 2 E's and the 2 L's. If there was another E, then this number would be 3.